Hello, welcome to this channel. My name is Enoch. Today we will continue our series on networking, and we'll be looking at the layer 4 of the OSI model, which is a transport layer. This layer is responsible for end-to-end communication and data delivery between hosts on a network. It plays a critical role in maintaining the reliability, integrity, and flow of data. It breaks down large files into smaller segments that are less likely to incur transmission problems. The file is divided into segments for transmission, sent over the network, assigned a sequence number for tracking, then reassembled at destination into the original file. Let's look at some of the functions of the transport layer. First, the transport layer divides data from the application layer into smaller manageable chunks called segments. It adds headers to this segment, which include source and destination port numbers for proper identification. Each segment is assigned a sequence number, allowing the receiving end to reassemble them in the correct order, even if they arrived out of sequence. And it ensures data integrity by validating sequence numbers, and checksum. And it manages the actual movement of this segment across the network using protocols like TCP for reliable delivery or UDP for fast best effort delivery based on the application's requirement. It ensures end-to-end communication, using unique port numbers to identify the application at the source and destination. And multiplexing is a process by which a host can support multiple sections or multiple applications simultaneously and manage the individual traffic stream over a single link. It combines data from multiple applications into a single transport stream. And the multiplexing is a situation where it delivers incoming data to the appropriate application using port numbers. It uses source and destination port number to identify specific section or application. For example, it knows that the HTTP is on port 80, so any application, any data stream that is with port 80 that has port number of 80 will go to the HTTP channel, and anyone that has port 443, it goes to HTTPS, and so on and so forth. So it implements error checking using checksums to detect corrupted data and retransmit lost or corrupted segments if using a connection-oriented protocol like TCP. It prevents sender from overwhelming the receiver by managing the rate of data transfer using protocols like TCP sliding windows. In TCP, it uses a three-way handshake and connection teardown to establish, maintain, and terminate logical connection, for communication. It uses a four-step process for a graceful connection termination. It ensures reliable data delivery using acknowledgement mechanism in connection-oriented protocol like TCP. The receiving host sends acknowledgement back to the sender. It is assumed that a segment is lost if acknowledgement is not received, and that segment will be resent. Port and port numbers in transport layers. As computers in the network are identified by individuals' IP address, applications in the network too are identified using their port numbers. So ports are logical channels that identify specific processes or application, and standard port numbers are categorized as well-known ports, which is from 0 to 1023. And for example, you have your HTTPS on 443, and you have your HTTP on port 80, you have your SSH on port 22, you have registered ports from 1024 to 49151, and they are used by specific applications like MySQL is on 3306, Grafana is on port 3000, and dynamic or private port, which uses port number from 49152 to 65535, and they are used temporarily by applications. And we can see an example of such in Apache Tomcat, which uses port 8080. We have RabbitMQ on 5672, and so on and so forth. And these are some protocols and their port numbers. You have DNS, you have HTTP on port 80, you have HTTPS 443, you have SMTP on port 25, and so on and so forth. You can just go through it and familiarize yourself with some of them. I also put some application and their port numbers here. You have your PostgreSQL on 5432. You have your Docker on 2376. You have your Prometheus on 9090. You have your Kubernetes API on 6443. And so on and so forth. You have to familiarize yourself with this port number and use them accordingly, in your CI/CD process. Let's look at some of the protocol in the transport layer. The first one is the UDP, which is the user datagram protocol. It's a connectionless protocol. It does not establish connection with the accepting device. At the other hand, it provides fast but less reliable data transfer without acknowledgement or retransmission. It is used in real-time application, like video streaming, online gaming, your YouTube, your Netflix, all these ones use UDP. And the other protocol is your TCP, which is your transmission control protocol. This is a connection-oriented protocol. It does a three-way handshake protocol to establish connection. It provides reliable data transfer with error correction, acknowledgement and retransmission. If acknowledgement is not received, the ASK segment is resent back, thereby ensuring that data that is sent is received at the receiving end. So it's used in applications where accuracy is critical, such as in your web browsing, in your email, or your file transfer. And it does a three-way handshake, for establishing connection. The client requests a connection by sending a sync packet to the server to initiate a connection, and the server acknowledges and agrees to establish the connection, thereby sending a sync ACK, which is synchronized acknowledgement packet. The client confirms the connection by sending an ACK packet to acknowledge the server's sync ACK packet. And there is also a four-way handshake, for graceful termination in TCP, where the client terminating connection send a fin message, which is a finished message, meaning that it is no more sending any data, and the server sends an acknowledgement, which is an ACK message, to acknowledge the message, and the servers then send a fin message, which is a finished message when it has finished sending all its own data, meaning it is no more sending any data, and the client will then send an acknowledgement, which is an ACK message acknowledging the message, thereby terminating the connection. Let's look at some difference between the TCP and UDP protocol. TCP is reliable, UDP is not reliable. TCP connection oriented, UDP is connectionless. TCP perform three-way handshake. UDP does not perform three-way handshake. Is a much faster protocol, and TCP provision for error detection and retransmission, and there is no acknowledgement in UDP, and most applications that need reliable and guaranteed transmission uses TCP. And UDP is suitable for applications where speed matters more than reliability. And an example of applications that use TCP is your HTTP or your Hypertext Transfer Protocol Secure, which is your HTTPS. An example of protocol that use UDP, DNS, DHCP, and so on and so forth. And let's look at the TCP model. As we discussed, layer 4 of the OSI model, which ensures reliable or unreliable data delivery using protocols like TCP and UDP, it is important to note that real-world networks, such as the internet, are primarily governed by the TCP IP model. You know, unlike the OSI model's theoretical 7 layers, the TCP IP model focuses on practical implementation and simplifies network communication into just 4 layers. And let us just quickly explore the TCP IP model in details and see how it aligns with and simplifies concept from the OSI model. The OSI model is more for educational purpose and troubleshooting purpose, but the TCP IP model is what is really used in real world networks. And let's look at it in details. The TCP IP model is just a practical real-world framework, that defines how data is sent, received, and managed over networks, particularly the internet. It was developed by the U.S. Department of Defense. It simplifies network communication into 4 layers instead of the OSI model's 7 layers. And the bottom layer is the network access layer, and data are in frames there. And the next layer there, which is the second layer, is the internet layer, and data are broken down into packets where your IP address are added. And at the third layer there is a transport layer, which where your data are broken down into segments for transmission. And the topmost layer there is the application layer, where your data remains as data, and everything together is called the protocol data unit, the PDU. And let's compare the TCP IP model with the OSI model in this place. The application layer in the TCP IP model correspond to the application layer, the presentation layer, the session layer in the OSI model. And we know that this layer provides services and interfaces for application to interact with the network. And we can see all the protocols that exist in this topmost layer. And the transport layer in the TCP IP model also correspond with the transport layer in the OSI model. And we know what happened in this layer. The protocol is at the same, the TCP and the UDP. And we know that this layer is responsible for end-to-end communication between application. And the next layer there is the internet layer, which in the TCP IP model, and it corresponds to the network layer in the OSI model. And we know that this layer is responsible for logical addressing and routing of data packets across networks. And the protocol there are the same, the IP, the ICMP, and the bottom layer in the TCP IP model, which is the network interface layer, correspond to the data link layer and the physical layer in the OSI model. And we know that in the TCP IP model, the data are in frames. In the physical layer, the data are in bits. In the data link layer, the data are in frames. So that's how they compare to each other. And let's look at some differences between the TCP IP model and the OSI model. We know that the OSI model is just a conceptual framework. It's more of educational purpose and troubleshooting purpose. Just is not tied to a specific implementation. And we know that the TCP IP model is what is used in the real world. We know that the OSI model is a 7-layered model, from the physical to the data link to the network to the transport to the section to the presentation and to the application layer. And we know the TCP IP model is just 4 layers, which is from the bottom is the network interface layer to the internet to the transport and to the application layer. And the OSI model is more of theoretical framework for understanding networks, and the TCP IP model focus on enabling internet communication. We know that OSI model is rarely implemented directly, but the TCP IP model forms the basis of the modern internet. That's that for today. Thank you for watching, and I will see you in the next video.